Examiner wants us to find the resultant and the direction of resultant where it is given in the question as such. So first let us split. 2 Newton needs no splitting. It is already purely vertical. So if I split this 12 Newton, this is 12 cos 25 and this makes 12 sine 25. On the other hand, when we split the force, which is 8 Newtons, is 8 cos of 10 and the vertical component is 8 sine of 10. All three forces are splitted, and now let's solve for the resultant. So sum of forces in x direction or horizontal, that is 12 cos 25 to right minus 8 sine 10 to left, and 2 Newton has no component in the horizontal direction. So 12 cos 25 minus 8 sine 10 leaves the answer of 9.49 newtons. Positive answer means it is moving towards right. Then sum of forces in y direction. So 12 sine 25 and then this 8 Newton is again upwards plus 8 sine, I'm sorry, let me make that correction. This was not sine, this is cos. 8 cos 10. Is this thing clear? I have changed it with cos. So it is 2.997. So I'm writing it as 3. And now on the other end, 12 sine 25 and 8 sine 10 is upwards. And we subtract 2, which is purely downwards. So 12 sine 25 plus 8 sine 10 minus 2. And we get 4.46. So this is my rough sketch. This is theta, this is r. To find r, we use the formula r is equals to square root x square plus y square, 3 squared plus 4.46 squared whole square root, 3 square plus 4.46 squared, we get 5.375 approximately equals to 5.4 newtons. Now about the direction. How can we find this direction? I already know that x is in positive direction making it 3, y is in positive direction taking it upward with 4.46 newton, and this right here would be the resultant. If I solve for this angle, I can later on subtract it from 90 to find theta, or directly we can find it on this side using 4.46 and 3 according to parallelogram rule. So tan of theta is perpendicular over adjacent, and tan inverse of 3 by 4.46 you get 33.9 degrees. So there were two requirements, resultant, here it is, and the direction theta. This is the answer. 3 coplanar forces of magnitude 68, 75 and 100 act at the origin. 68, 75 and 100 they act at the origin as shown in the diagram. The components of 3 forces in the positive x direction are minus 60, 0 and 96. So this negative 60, where does this belong? With the 68. Yes, right. So this should be minus 60. And if I'm already drawing it towards left, so I'm not mentioning negative sign there. 0 is with 75 because that's a perfect vertical force, and then 96 lies right here. So we know this. And then it says respectively find the component of three forces in the positive y direction. So one by one, what is the component of 75 force in y direction? That is 75, because this is perfectly vertical. What about this 68 Newton force? That's right. That's right. That is right, 32 newtons, and it is downwards, so I should mention minus 32 newtons. And in the same way, we solve for the 100 Newton force, that is 100 squared minus 96 squared whole square root. That's 28, it is downwards, so minus 28. So we are done with the first part. Second part says the magnitude and direction of resultant of these forces. Now for resultant, we follow our scheme, that is sum of forces in x direction, which is already given. So minus 60 plus 0 plus 96, and I get positive 36 newtons, right? And for sum of forces in y direction, we've just completed them. So 75 minus 32 minus 28 is 28, 15, right? So we now know that x is 36 positive, so we take it to right, and this is 15 upwards because it is again positive. So my resultant would be 15 squared plus 36 squared whole square root. (39). So magnitude is 39 newtons, and direction we can find this angle, and theta is equals to tan inverse of perpendicular over adjacent. Which is 22.6 degrees. Now be sure to write that in proper words. If this is 22.6, this is with the horizontal. Either we say the direction is 22.6 with the positive x-axis, or we mark it on the diagram, or you answer it in bearing form. All three are acceptable. Yes, that's right. 90 minus 22.6, which is 67.4.